Hello everyone, so today we are adding fractions with non-common denominators. The denominators are different. So you got 1 over 21 plus 7 over 45. Now, one thing that I wanted to mention is that what I do here applies to subtraction of fractions with different denominators, as well as adding or subtracting more than two fractions with different denominators, okay? So the first step here is I'm going to find the common denominator by factoring each denominator into a prime factorization, okay? So what does that mean? That means that you're going to take 21, take 45, and you're going to factor it. So you're going to ask yourself, so what times what gives me 21? Well, 7 times 3 gives me 21, and that's it. That's where I stop because that's the prime factorization. Now 45 is 9 times 5, and then 9 itself is 3 times 3. And that's it. That is the prime factorization. So you basically break down the number, and any of the factors you try to break down further. And what I'm going to do here is I'm going to take the prime factors, these numbers. So 21 is like saying 3 times 7. And then 45 is like saying 3 times 3 times 5, or 3 squared times 5. Okay? Now, the way you grab specifically the lowest common denominator is what we're looking for. You can have, with two fractions, you can have more than one denominator. There's actually an infinite. But we're in particular interested in finding the lowest common denominator because that makes things a lot easier. And the way we do that is by my description. I have grabbed the largest group of each prime number, and this put together is your LCD. So let me get into that. So we have that 21 is 3 times 7, and then you have 45 is 3 squared times 5. And the way you get the LCD is as follows. You're going to start with, doesn't matter the number you start off with that you see in the list, the 3, 7, or the 5. I'm going to grab just the smallest one, which is 3. And the largest group of 3's that I'm speaking of is 3 squared, because 3 is raised to the power of 2 there. So that's the quote-unquote largest group of 3's. And then you go to your next number here, which is 5. Which is the largest group of 5's? Well, just have one 5. And then finally, what's the last largest group of 7's? You only have one 7, so that just stays. So your LCD here is 3 squared times 5 times 7, which, let's see, would come out to 3 squared, that's 9 times 5, 45 times 7. And 45 times 7 here is equal to 35. 4 times 7, 28, and 3, 315 here, okay? So we're going to have 315 as my LCD. And here's the next part that we're going to work with. You're going to multiply each denominator by a constant in order to make the LCD. Do this to the numerator as well. So we're going to go back to our fractions, which were 1 over 21 plus 7 over 45. And the LCD here was 3 squared times 5 times 7, okay, which was the 315. And there's a couple ways of doing this. You're going to ask yourself, 21 times what would give me 315, okay? And if you're good at multiplication, meaning you can kind of do it quickly, you would find out that that's going to be 15. So you'd multiply the top and the bottom by 15. And the 45, you're going to ask yourself the same question. 45 times what gives you 315? So again, if you're okay with your math, you would say 45 times 7. So 7 times 7 as well, which would give you 15 over the 315 plus 49 over 315. And that's what we would work with in my next step, which would be adding the numbers in the numerators. Now, before I do that, let me go back to an alternative way of doing this, because, right, some people, they're not too, quick with their multiplication tables. I understand that. So the other way you can do this step where I multiply by the 15 and the 7 is as follows. So I'm going to take the breakdown of the LCD, which is the 3 squared times 5 times 7, and I'm going to go ahead and take the breakdown of the 45 and the 21, which we had earlier, 3 times 7 for 21, 3 squared times 5. And here's what you're going to ask yourself. What is missing from each of these groups of 3s, 5s, and 7s on 45 and 21 that are on the LCD? So notice how 45 has 3 squared 5 in there. Well, it's missing a 7, so you would multiply the 45 by 7 up on the fraction. And notice what's missing from the 21. Well, the LCD for 315 has a 3 squared, so it's missing 1 3, and it's missing a 5. So it's missing a 3 and a 5, so 3 times 5, 15. Or you can just put 3 times 5, then 3 times 5, or 3 times 5, just 15. It's up to you. Okay. So that's the other way to figure out what you need to multiply by. You look at the breakdown of the LCD, and you look at the breakdown of your 2 fractions or 3 fractions, whatever number of fractions you have, and you ask yourself, what's in the LCD? Again, what's in the LCD that's missing from the 2 denominators of what's missing from 45 and 21? All right, so now we get to the point where we have 15 over 315 plus 49 over 315. And yeah, we're just going to add these up, and this gives you 64 over 315. And last but not least is if you could reduce this fraction, we often ask you to do so. And you'll see the word simplify if necessary. So basically that's indicative of you to simplify by reducing. So is there a number that goes into both 64 and 315? And there is not. Nothing divides both 64 and 315. Okay. So just to kind of recap what we did real quick, go back to step 1. You're going to break down the 2 denominators, which were the 21 and the 45. And we broke them down as you saw. And what you were going to do now is from those factorizations, you're going to grab the largest group of each of these numbers, and that makes your prime number. So 21 was 3 times 7, 45 was 3 squared times 5. And then we said to ourselves, well, okay, what's my LCD going to be? Starting with 3, I said, well, the largest group of 3 is 3 squared. The largest group of 5 is 5, and the largest group of 7 is just 1 7. Yeah, and you do that with all the numbers that you have on the prime factorizations. And we multiplied it out, and it's equal to 315. And then your next step here was to multiply each denominator by a constant in order to make the LCD. So you do this to the numerator and denominator as well. So we said to ourselves, what do I need to multiply 21 by to get 315? There's a couple of ways of doing this. We said, well, 15. We multiplied on the top and the bottom by that, and then by 7 on the 45, and the top and the bottom there, the numerator and denominator on the 7/45 to be more specific, and the 1 over 21, we did the same thing. So that was one way. The other way was, what you could do is you could get the prime factorization breakdown of each number, which was the 3 squared times 5 and the 3 times 7. And for the 7 and the, for the 45 and the 21, and then ask yourself, okay, what number is missing from each of the 45 and 21 that is on the LCD? So 45 is, you have a 3 squared and a 5, but it doesn't have the 7 that the LCD does, so you would have to multiply by 7, so that's what you multiply your fraction by 7. And on the 7 over 45, excuse me, you multiply both the numerator and denominator by 7. And then for 21, it was 3 times 7. And what's missing from that factorization of 21? It's on the LCD. Well, you're missing an extra 3, because there's 2 3s and a 5, so 3 times 5, 15. So we multiplied 1 over 21 by 15 on both the numerator and denominator. And so that's how that goes. And 15 times 1 is 15, 7 times 7 is 49, as we said, and that common denominator is 315. And yes, it's when we write the common denominator, we like to write it out whole as such. And you add those numbers, you get 64 over 315, and that's it. In this case, we cannot reduce the fraction. It stays as it is. But if I did have 64 over, let's say, 20 for a moment, you know, what goes into both 64 and 20? 2 divides both of them, but also 4 does. So I could divide both the numerator and denominator by 4. So this would be 16 over 5. Okay, so that's what we mean by reducing the fraction, to be more specific here. All right, well, thank you so much for your time, and I hope this helps.